Hi everyone, it's such a pleasure to be here today to give this talk about Caroline Herschel and comets, asteroids and meteors. My name's Dr Sheila Kanani. I'm the Education Outreach and Diversity Officer at the Royal Astronomical Society, and I'm also a children's author and science ambassador. It really is a pleasure to be able to talk to you today given the current climate, and I will be available for questions at the end of the talk. Enjoy. In this talk, I will combine the story of a pioneering woman astronomer with an account of the science behind comets, asteroids, and meteors. So, Caroline Herschel began her life in astronomy by supporting the work of her amateur astronomer brother, William. She was working with him when he discovered the planet Uranus. She went on to become the world's first professional woman astronomer, and her salary was provided by King George III of Great Britain. The catalogue of nebula that she produced brought her the Royal Astronomical Society's 1828 gold medal, the first awarded to a woman. And the next gold medal awarded to a woman wasn't until 1996. And even since then, there have only been a handful. So in Caroline's life, she discovered 8 comets, personally discovering 5 of those. And she was only the second person to discover Comet Encke. She also worked as a team with her brother and her nephew. And with that team, William and Caroline increased the number of known nebula from about 100 to about 2,500. And in this Cinderella story, where the prince is astronomy rather than a man, I will give you an account of Caroline or Lena's life, showing you what a pioneering woman she was, even back in the 17 and 1800s, when being female was far more of a penalty than a success. Interwoven with the science behind the astronomy that she was particularly famous for. So I've had a really varied life in terms of my career. I decided that I would like to be an astronaut when I was about age 13. And I went to the library to read about astronauts and their career paths. And I learned that there was a few astronauts who had got to where they were today by taking the academic route, particularly one, Michael Foale, who had done astrophysics, a PhD. So when I was 13, I decided that I was going to do a PhD in astrophysics as well, which I didn't really know what that meant back then, but I continued down that path. And I've been lucky enough to study physics and astronomy since then through school and university. I've been to space camps and space schools all over the country and the world. I've been a research scientist working on the Cassini team looking at the planet Saturn. And I've also looked for exoplanets using radio astronomy and radio telescopes in the outback of Australia. Throughout my career, I've also realised that I like teaching and talking about science as much as I like doing it. So I have been a fully qualified teacher, science teacher, for quite a few years now. I've taught at Space School UK for 10 years, and I've also taught full-time in secondary schools. But then the job at the Royal Astronomical Society came up in 2014, and that brought together all my passions. So my passion for teaching and my passion for space. And I've been working there ever since. So I'm the first to admit that Caroline was only really introduced to me back in 2014 when I started my job at the Royal Astronomical Society. But she quickly became a firm favourite in my storytelling as a role model in astronomy and a really formidable creature to look up to. Now, of course, you couldn't really have looked up to her. So I only really say that in the respect sense of the word, because she was only 4'3". So even I, at about 4'10.5", would be looking down on Caroline if I were ever to meet her. Now, the Royal Astronomical Society is based in central London. Obviously, the buildings have been closed for quite some time now, but when things do start to open up again, go and have a look at Burlington House on Piccadilly. It's really quite remarkable. The Royal Astronomical Society is there, but also the Royal Society of Chemistry, Geology, the Linnean Society, and the Royal Academy of Art. William Herschel was our first president, so the Royal Astronomical Society's first president, back in 1820. So 2020 was the bicentenary of the Royal Astronomical Society, and we were going to celebrate that in lots and lots of different ways. This talk was one of those celebrations. Now, I like to show pictures of past presidents of the Royal Astronomical Society. So on the bottom left-hand picture is William Herschel, and next to him is our second to last president, Professor John Zarnecki, a planetary scientist like myself. And I like to show those two pictures next to each other because you can see even in 200 years, even the face of astronomy hadn't really changed, which is why I like to celebrate women astronomers like Caroline Herschel. So Caroline was first trained to be the assistant to her astronomer brother. And then William discovered the planet Uranus and was the first president of the RAS, although he never actually chaired a meeting. His 40-foot telescope was the main symbol on our logo until last year, when the logo was updated as part of the bicentenary. And Caroline was the first woman to win our prestigious gold medal in 1828. At that time, however, women were not allowed formally to be members of the Royal Astronomical Society. So Caroline wasn't allowed to become a fellow, but instead she shared an honorary membership with Mary Somerville in 1835, which was sometime after she actually won her award. So even though she was so incredible, she had a hard time being formally recognised for the things that she did back then. When I joined the RAS and was taught about Caroline Herschel by the wonderful librarian and archivist, Dr. Sian Prosser, I have been on a whirlwind journey of learning about her because she has really inspired me. I've learned about her incredible life and her astonishing astronomy, including the legacy that she left behind. And I take every opportunity to celebrate her work and her life and use her as an inspiration to all budding astronomers from any background. Because if one tiny, ill-ridden drudge can win a gold medal, anyone can. So Caroline Lucretia Herschel, or Lena, was born in the German town of Hanover on March the 16th in 1750. She was the 8th child of Isaac Herschel and Anna Ilse Moritzen. Isaac was a talented musician, while Anna was illiterate and vehemently opposed to the education of girls, believing that they should work only at home. Isaac became a bandmaster in the army and was away with his regiment for substantial periods of time, whilst Caroline was young. The family had to move house a lot because of financial reasons, and Anna, Caroline's mother, took on work wherever she could find it. Isaac suffered ill health after the Battle of Dettingen in 1743 and never recovered fully. He suffered a weak constitution, chronic pain, and asthma for the remainder of his life, and he was then home for longer periods of time than Caroline's mother. Caroline suffered from smallpox when she was about 3, leaving her face pockmarked, and at 10 she suffered from typhus, permanently stunting her growth. Her parents believed that these physical issues would make it difficult for Caroline to find a husband, and so her mother decided Caroline would learn how to do domestic chores and serve as the family's house servant. Anna objected to Isaac's attempts to educate his daughters, even opposing to violin lessons. Isaac still taught Caroline directly when Anna was away from home, and included Caroline secretly in her brother's French and maths lessons. Not being allowed to learn French annoyed Caroline particularly because it destroyed her chances of becoming a governess, which demonstrates Caroline's aspirations. And her accounts of her childhood show an intensive daily routine. Her schooling meant that she learnt to read and write, which was unlike many women from the generations before her. And it was typical of her education that this skill was immediately put to use writing letters for her mother and any other illiterate army wife in the neighbourhood. She was sent to tutors after school to learn knitting and how to clean silk. And when opportunities arose to gain new skills, Caroline actively sought to capitalise on them. She was proactive, even when she was young. Caroline was taught millinery and dressmaking, and she enjoyed hard work. And even as a child, she wanted to appear to be able to support herself one day. The lessons she sought for herself were those that might make her appear of a higher social class and could have led to paid employment. However, in the Herschel home, such ambitions were forbidden. When, for example, she had been allowed to attend these lessons in millinery and dressmaking, it was under the strict agreement that it should be to make clothes for her and her family only, and not for commercial gain. To train girls for work outside the home was considered by the Herschel family to be a much lower class pursuit, and so she was not encouraged to do so. In 1771, Caroline, then aged 22, began to wonder where her future lay. She said, "I had by this time imbibed too much pride for submitting to take place as a lady's maid, and for a governess I was not qualified, for want of knowledge in languages. And my father has cautioned me against all thought of marrying, as I am neither handsome nor rich." With marriage and service and teaching all ruled out, Caroline's options were extremely limited, and William's offer to bring her to England to act as his housekeeper and learn to become a singer gave Caroline an escape she could take. After Isaac's death in 1772, William managed to persuade their mother that Caroline should join him, and eventually Anna allowed Caroline to move to England. In August 1772, William took Caroline with him to Bath. He agreed to pay his mother for a servant to replace Caroline, and on the journey to England, she was first introduced to astronomy by way of the constellations and opticians' shops. During the trip, they sat atop the carriage and William showed Lena the constellations for the very first time. Between 1772 and 1781, Caroline lived with her brother in Bath. There, she took on the responsibility of running the household, and she also learnt to sing. William had established himself as an organist and music teacher at 19 New King Street in Bath, Somerset, which is now the place of the Herschel Museum of Astronomy. He was also the choir master of the Octagon Chapel and a church organist. William was busy with his musical career and organising public concerts. Life in Bath was not easy for Caroline. She was relatively poorly educated and spoke little English. She did housework for William, who taught her English and maths as well as singing. Breakfast was always taken with a maths lesson. Geometry she learnt the hard way. If she did not know the angle of the piece of cake she wished to eat, she had to go hungry. Caroline was also given lessons in presentation to learn how to perform and behave among the employees of musicians. This meant that she learnt some of the rules of appropriate female behaviour that she would later apply in the presentation of her science. Nevertheless, it appeared that Caroline did not blend in with the local society and made few friends. Caroline took several singing lessons a day from William, and within 5 years she was a notable soprano singer. She became the principal singer at his oratorio concerts and acquired such a reputation as a vocalist that she was offered an engagement for the Birmingham Festival, but she declined to sing for any conductor except for her brother William. This meant that eventually people stopped requesting her, and she found herself without concerts to perform in. Her career in singing began to decline. Mrs. Bowman, the housekeeper, had helped Caroline master English cooking. Teachers had been employed to teach her etiquette and presentation. William had helped her learn English, singing, and some basic maths and accounting. And next, the siblings turned their attention to other areas of mathematics. After her initial accounting tutorials, Caroline's lessons evolved into something quite different. These little lessons for Lena, as they were called, subheaded a little geometry for Lena, a little algebra for Lena, and so on, started with geometry and algebra, including topics such as angles in a triangle and Z angles. Both algebra and geometry were considered essential prerequisites for the study of fluxions, an area of mathematics that William was then studying, that we now call differentiation. The lessons also incorporated some of the astronomy that William was beginning to study. In one lesson, for example, certain trigonometric rules were taught. In the next, astronomy-related problems were set in which those rules might be used, such as finding the position of one star in relation to another. It's unclear who initiated these lessons or why. For William, Teaching Caroline offered him the opportunity to test how well he understood what he had learnt so far. This was the style of learning that he had been taught as a child. In addition, having a sister with some knowledge of advanced mathematics would have added to his family reputation as Bath's mathematical musicians. For Caroline, her acquisition of mathematical skills allowed her to play a greater role in William's life and thus further securing her position in her new family home. About a year after Caroline arrived in Bath, in the summer of 1773, William began his new hobby, building his own telescopes, and this changed the look of the house entirely and the life of its inhabitants. It was to my sorrow that I saw almost every room turned into a workshop, Caroline declared with regret. Although initially appalled at what this meant for the house, Caroline later recognised the educational opportunity offered to her through his new hobby, and she took advantage of it. At first, however, her role in instrument making was minimal. Her musical and domestic duties took precedence. Throughout this period, both William and Caroline were using their ability to absorb skills and knowledge to develop new roles for themselves. While William was gradually becoming more astronomer than musician, Caroline was busy making herself indispensable in every way of William's life. William's passion for music was decreasing, and his passion for astronomy was increasing. He felt driven to understand the heavens better than anyone before. He desperately wanted to see objects so faint that nobody had ever seen them. To achieve his goals, he needed the greatest telescopes in the world. The only way to get them was to build them himself. And soon the Herschel's drawing room became a stand construction workshop. A bedroom became a glass grinding operation, and the whole house took on the odour of horse dung, which was pounded into a dried, non-porous loam mould for mirror casting. With William becoming so obsessed with his goals that, in addition to helping him grind mirrors and lenses using horse dung, Caroline often had to prepare food and feed it into his mouth as he worked. She said, "I did nothing for my brother, but what a well-trained puppy dog would have done. That is to say, I did what he commanded me." William's reputation as a telescope maker grew to such an extent that he quit his job as a musician and devoted all of his time to the making of telescopes and to astronomy. Caroline began to help her brother in the manufacture of telescopes and to share his passion for astronomy. She first served as her brother's apprentice and then began to function more and more on her own and went on to help her brother develop the modern mathematical approach to astronomy that we still use today. Although both Herschels maintained journals corroborating their joint work in their endeavours, when the story of Uranus's discovery is told, William is often credited as a male genius who had a eureka moment on March the 13th, 1781, when in fact it was a collaboration. When Uranus was discovered, it was a singular moment in the history of science. If a planet had remained unrecognised for so long, what else might be out there? After all, Uranus was actually visible to the naked eye. The mathematicians of the Royal Society concluded that Herschel had discovered a new planet, the first that was further from the Sun than Saturn. The finding changed the perception of the solar system. It was larger than previously thought and could hide even more distant planets. British scientists petitioned the king, asking that Herschel be paid a government pension to allow him to give up music and devote his life to the construction of his magnificent telescope and the possibility of making further stunning discoveries. The king agreed, and William became a full-time astronomer. William was paid £200 per annum. He assumed Caroline would also be happy to give up her musical career to act as his assistant, which she did so, but initially reluctantly. In his new role as the king's astronomer, William was required to move to a house near Windsor and be on call to show the royal household the heavens whenever they wished. The pension was generous enough to allow William to take Caroline with him, and so the two of them packed up and moved to Slough. Caroline was far from happy. She had escaped drudgery in Hanover to become a singer, praised and loved by audiences. She now had to abandon her singing and the excitement of Bath to live in Datchet, a small village near Windsor Castle, closer to the king. Her first months as a full-time astronomer were miserable and lonely. They moved several times in the first few years before eventually settling on a property later known as Observatory House. On arriving in their new home, Caroline states, "I found I was to be trained for an assistant astronomer, and by way of encouragement, a telescope adapted for sweeping was given to me. I was to sweep for comets. I began August 22, 1782, but it was not till the last 2 months of the same year before I felt the least encouragement for spending the starlight nights on a grass plot covered by dew or hoarfrost without a human being near enough to be within call." In instrument making, Caroline's approach to education showed itself to be a good complement to that of her brother, helping them to work as a unit and to turn William's ideas about his telescope mirrors into reality, often by supervising the workmen when William was away. Having carved out a role for herself within the family's instrument-making project, Caroline then began to take more control over other aspects of her education. In this period, she actively pursued an understanding of the mathematics and astronomy that her brother was studying. Her little lessons for Lena became answers to the questions that she put to her brother. She was now setting the topics herself, selecting areas of mathematics that she felt she needed to study, and quizzing her brother, although the content suggests that the questions came out of the broader task set by William. Her notes contain, for example, theorem for determining the field of view by the passage of a star, or rules for making use of astronomical instruments, and theorem for calculating the number of stars that have been seen in a sweep. In each of these sections, it is possible to see a direct relation between the rules and theorems laid out and the task she was assigned in her role as an astronomical assistant. One page, for example, Caroline was introduced to the 8 classes of nebula and the 6 classes of double star. This was from a new classification system devised by William, and these lessons offered an opportunity for him to test out and talk through his ideas. William's interest in astronomy started as a hobby to pass time at night. At breakfast the next day, he would give an impromptu lecture on what he had learnt the night before. Caroline became as interested as he did, stating that she was much hindered in my practice by being continually wanted in the execution of the various astronomical contrivances. This basically meant that she wanted to spend more time on astronomy, but actually she had to spend her time helping her brother. Caroline possessed incredible dexterity in polishing mirrors and mounting telescopes. She learned to copy astronomical catalogues and other publications that William had borrowed. She also learned to record, reduce, and organise her brother's astronomical observations. She recognised that this work demanded speed, precision, and accuracy. The new job proved to be a mixed blessing. Although it left William with a lot of free time to continue his astronomical observations, it also meant a reduction in income and being called upon by the king for entertainment whenever he desired. During this time, William perfected his telescope making, building a series of larger and larger devices that ultimately ended with his famous 40-foot or 12-metre focal length instrument that was used to house parties for the king. The telescope was a local tourist attraction, visited by rich and famous people on their way to nearby Windsor Castle to visit the king, and was featured on Ordnance Survey maps. It was the largest telescope in the world for about 50 years. William Herschel's son, John, took down the telescope frame at the end of 1839. It was dismantled because it was feared that the frame might collapse due to rot, and John was worried for the safety of his young children. A small ceremony was conducted to commemorate its dismantling. The tube was left lying horizontally in the garden, supported by stone blocks at either end, where it was crushed in 1867 by a falling tree. The remaining piece is a 10-foot or 3-metre length of the mirror end, which was still located in the garden of Observatory House in 1955, but has since been moved and is now located in the Herschel collection of the National Maritime Museum in the Royal Observatory, Greenwich, London. Caroline was William's constant assistant in his observations, also performing the laborious calculations with which they were connected. During one such observation run on the large telescope in 1783, Caroline became caught on an iron hook. And when she was helped off, she said, "They could not lift me without leaving nearly 2 ounces, 60 grams, of my flesh behind." Very dedicated to the cause. Caroline began to make observations on her own in 1782. During her spare time, she occupied herself with observing the sky with a 27-inch focal length Newtonian telescope. And it was with this telescope that she detected a number of astronomical objects during the years 1783 to 87, including her first independent discovery, M110 or NGC 205, which is the second companion of the Andromeda Galaxy. Messier 110 or M110, also known as NGC 205, is a dwarf elliptical galaxy that is the satellite of the Andromeda Galaxy. Although Charles Messier never included the galaxy in his list, it was depicted by him, together with M32, on a drawing of the Andromeda Galaxy. A label of the drawing indicates that Messier's first observation of NGC 205 on August the 10th, 1773. The galaxy was independently discovered by Caroline Herschel on August the 27th, 1783, so 10 years later. Caroline became an effective sweeper of the sky using her Newtonian, ingenious in its simplicity. The tube rotated in a vertical plane as Caroline wound a cord. By keeping her eye at the eyepiece and turning a handle, Caroline could search a vertical strip of sky as the tube moved from the vertical to the horizontal. In the time this took her, the rotation of the heavens had brought into view the next strip of sky, and so on. In a few evenings, she could search the whole of the visible sky. This was a very clever contraption indeed. So asteroids are small rocky objects that orbit the sun. Although asteroids orbit the sun like planets, they are much smaller than planets. Meteoroids are significantly smaller than asteroids and range in size from small grains to 1 meter wide objects. Most are fragments from comets or asteroids, whereas others are collision impact debris ejected from bodies such as the Moon or Mars. They are meteoroids in space. They are meteors when they fall through our atmosphere, and if they survive to the surface of the Earth, they are called meteorites. This is the Barringer crater or Meteor Crater in America, and this would have been created by an impact of a meteorite on the surface of the Earth. And in February 2021, you might have heard of the Winchcombe meteorite, which predominantly landed on the driveway of an anonymous donor in Gloucestershire in Winchcombe. That was the first time the UK had a viable meteorite or a significant meteorite land in England in the last 30 years, and it's now homed at the National History Museum. It didn't make a crater this big in the driveway of this poor unsuspecting person, but it did make a little bit of a mess. And then we have comets, which are basically giant dirty snowballs that live at the edges of our solar system, past Pluto, in a place called the Kuiper Belt and the Oort cloud. They are made from the remnants of materials from when the solar system was formed. And because this area is so far away from the sun, it's very, very cold. And the main component of a comet is ice. So that's why we talk about comets as huge, dirty snowballs. Objects found in the Oort cloud are known as trans-Neptunian objects, and this applies to all objects beyond the orbit of Neptune and includes the Kuiper Belt objects as well. The Oort cloud comprises of 2 regions. There's the spherical outer Oort cloud and a disc-shaped inner cloud called the Hills cloud. And objects in the Oort cloud are mostly composed of water ice, ammonia, and methane. The estimated number of objects believed to be in the Oort cloud is around 2 trillion, although there is currently no way to verify this theory. And long-period comets with orbital paths of over 200 years are believed to originate in the Oort cloud, according to many astronomers. And so you see here we have a map of the Oort cloud comprising of many billions of comets. And the Oort cloud and the Kuiper belt extend way out, and our solar system is just a tiny little speck in the middle there of the Oort cloud. Now, comets are often referred to as dirty snowballs. They're left over from the formation of stars and planets from billions of years ago, and they're composed of rock, dust, ice, and frozen gases such as carbon monoxide, carbon dioxide, methane, and ammonia. They have a sort of sparse atmosphere called a hydrogen cloud, which is an envelope of neutral hydrogen, and a coma, which is a dense cloud of water, carbon dioxide, and other neutral gases that are sublimed or go from a solid straight to a gas state without becoming a liquid from the nucleus. Then there are two tails of a comet, the ion tail and the dust tail. The ion tail can extend up to several hundred million kilometers, and it's composed of plasma laced with rays and streamers caused by interactions with the solar wind. And because it's charged particles in a plasma, it interacts with the sun's magnetic field. And so this tail always points directly away from the sun. And then there is the dust tail, which is up to 10 million kilometers long, mostly made from smoke-sized dust particles driven off the nucleus of the comet by escaping gases. And this is the most prominent part of a comet to the unaided eye. Dust particles from the tail generally point back along the comet. So if the comet is traveling towards the right, the dust tail extends to the left. And then we have the nucleus, which is the solid, stable, central part of the comet, mostly ice and gas, with a small amount of dust and other solids. So this is what the central part of a comet looks like. You've got the nucleus, which is made of a rocky, icy core, and then the coma, and then the hydrogen envelope, and then the dust tail and the ion tail. Comets have highly elliptical orbits, which is unlike any other object in the solar system or any other solar system body. And what this means is that whilst they orbit the sun, they spend most of their time at the outer edges of the solar system in the Kuiper belt and Oort cloud, and then shoot in towards the sun. And as they approach the sun, the cometary material starts to alter from an ice to a gas, and the comet tail appears. And this highly elliptical orbit also gives a comet its period. So the short period comets are the ones that take 200 years or less to orbit around the sun. So we would see them on a regular basis. So for example, Halley's Comet, which orbits the sun in, I think it's every 76 years, or the long period comets, which take longer than 200 years, and their period could be 2,500 years. And maybe we've seen one so far that we know about, and maybe we haven't. So radiation from the sun pushes the dust particles away from the comet, forming the dust tail, and the charged particles from the sun convert the cometary gases into ions, forming the ion tail. And as the comet gets closer to the sun, the ice on the surface of the nucleus begins to turn into a gas, forming the cloud that we have called the coma. And the radiation from the sun pushes the dust particles away from the coma, forming the dust tail, while the charged particles from the sun convert some of the gases at the comet into ions, forming this ion tail. The tails always point away from the sun and get longer the closer the comet gets to the sun. So the visibility of the comet changes. It means that the closer to the sun the comet gets, the more obvious in the sky they become for us, because when they're very far away, comets are very dark in nature because of what they're covered in. But as they get closer to the sun, the surface starts to change, comets become more visible, and then the ion and the dust tail are created. And when we see comets in the sky, the main feature that we see are the tails. So the bigger the tails are, the more visible comets are to human beings. Now, humans have been able to witness comets for centuries with no equipment. And so in the past, it was thought that comets were hairy stars, which is where they get their name. And people used to fear comets as harbingers of doom, as you can see in these pictures. And it's quite interesting to note that the top right picture is the Bayeux Tapestry from 1066. And there is a comet embroidered into that. So we really have known about comets for thousands of years. Modern technology has allowed us to view comets in very different lights. These are various different photographs, some taken from the surface of the Earth and some taken from space. And you can see how the tails can vary depending on how close to the sun the comet is. The bottom left picture was taken in the 1990s. It's Comet Hale-Bopp, and I remember seeing this as a child, and it was visible in the sky for at least 2 weeks, if not more than that, and it was absolutely stunning. Now, the next great comet is going to be Comet Halley, which is due in 2061. So just have a think to yourselves right now how old you might be in 2061. I really like this picture as well. This is Comet Lovejoy, visible near the Earth's horizon in this nighttime image, photographed by an astronaut, Dan Burbank, who was actually on the International Space Station when he took this picture in 2011. There have been various missions to comets over the years, including Giotto, Stardust, and Deep Impact. Giotto flew behind the comet, and Stardust measured what the atmosphere around the comet was made up of. And the Deep Impact mission basically fired bullets at the coma, at the snowball part of the comet, to see what the ejector was made from, to learn more about comets themselves. And then more recently has been the Rosetta Mission, which was a part European mission in 2014, and orbited Comet 67P for 17 months and landed the Philae lander onto the surface of the comet and took some incredible photographs as well. Now, the Philae lander was about the size of a washing machine. It landed on the surface of the comet, which was an incredible feat of technology in itself. But unfortunately, it was a solar-powered lander, and it landed in a crevice in the dark, and so wasn't able to carry out the scientific exploration that it wanted to. But even so, the Rosetta mission, the orbiter, and the fact that the landing was successful was an incredible feat of technology and engineering that we simply couldn't have done 50 years ago. So our knowledge of comets is increasing exponentially. And it's because of missions like these that I'm able to use the information that we learn to do classroom activities like building a comet with school children. Now, one of the reasons we care so much about comets is because comets and the Earth were very similar when the solar system was formed. And the Earth has changed a lot over the last 4 billion years, but comets, because partly they are so far away from the sun, have remained largely unaffected. So if we learn more about comets, we can learn more about the Earth and where we've come from. One of the other reasons that we're interested in comets is because of Comet Impacts. And it was possibly a comet impact 66 million years ago that caused the extinction of the dinosaurs. And there are some theories that suggest that the Earth used to be barren, and a comet brought the water to the surface of the Earth. So a comet impacted with the Earth and melted, and comets are made up of water, amongst other things, and gave water to the Earth. And that would be a really interesting theory if that was the case. Now, Comet 67P, the one that was investigated by the Rosetta mission, is about 4,000 meters or 4 kilometers across. So if it landed very gently, it would stretch across the whole of central London. But obviously, comets and other objects in space, like asteroids and meteorites, are not traveling slowly. So we do check to see what potentially hazardous objects, near Earth objects there are in space, so that we are able to track these types of things in the sky, just in case they are to or were to impact us. And there are options if we do find something that is going to crash into the Earth, if we find it in time anyway, before it actually does crash into the Earth. So going back to Caroline's life, between 1786 and 1797, she discovered several comets and worked on a reorganisation of John Flamsteed's star catalogue. So both these projects gained her public recognition and praise within the astronomical community. And beginning in October 1783, the Herschels used a 20-foot reflector to search for nebulae. Now, initially, William attempted to observe and record the objects, but this was inefficient and he turned to Caroline. So when a nebula or a massive cloud of dust and gas came into view, he would pull a cord that communicated with a bedroom overlooking the telescope where Caroline was waiting at a desk. And she would open the window, copy down William's shouted description of the appearance and location of the nebula, and the location would be by reference to a nearby star, which Caroline would identify. This wasn't a particularly simple clerical task, though, because she would have to use Flamsteed's catalogue to identify the star. And the catalogue was organised by constellation, which was less useful to her, which is why she created her own catalogue, organised by zones rather than constellations, which meant that William could use a catalogue in zonal sweeps of the sky. The morning after each session, Caroline would go over her notes and write up formal observations, which she would call minding the heavens. And this was, as she put it, a project that would give her something useful to do when William was busy. And she said, I had always in hand some kind of work with which I could proceed without troubling him with questions, such as the temporary index, which I began in June 1787, and some years after, the index to Flamsteed's observations. Like her catalogue, Caroline's comet discoveries came out of work she was doing with her brother. His project, which was to survey the sky for nebula, star clusters, and double stars, was an update of a catalogue originally produced by Charles Messier to identify and list objects for the benefit of comet hunters, because such objects were frequently mistaken for comets. Caroline's comet hunting was this project in reverse. So it was about learning to tell the difference between one blurry object in the night sky and another. She discovered her first comet on the 1st of August 1786, the next in December 1788, two more in 1790, a fifth in 1791, another in October 1793, her seventh in 1795, and in August 1797, she discovered her eighth and her final comet. The timing of these discoveries almost all occurred when William was away. Now, she's often credited as the first woman to discover a comet, but this isn't true. Maria Kirsch discovered a comet in the early 1700s, but she's often overlooked because at the time the discovery was attributed to her husband Gottfried. So by July 1786, Caroline had set a strict routine for herself as an astronomer rather than a housekeeper. She checked the calculations of William's nebula by day and made her own sweeps on the roof by night, normally using her specially constructed Hunter's telescope. And on August 1st, 1786, Caroline spotted an object moving through the sky. Caroline's triumphant finding, Comet C/1786P1 Herschel, became known as the First Lady's Comet. Its publication by the Royal Society, an almost unheard of rarity for a female correspondent, catapulted her to international fame. At the time, only about 30 comets had been identified and recorded. In 1788, Caroline discovered the period comet 35P Herschel-Rigolo. This comet will return in 2092, for any of you that will still be alive then. William was summoned to Windsor Castle to demonstrate Caroline's comet to the royal family, and he recorded this phenomenon himself, terming it "My Sister's Comet." So she was given an annual salary of £50 per year by King George III for her role as assistant to William, and this would be approximately £6,000 in today's money. Caroline's appointment made her the first woman in England honoured with an official government position and the first woman to be paid for her work in astronomy. Now, throughout her writings, she repeatedly made it clear that she desired to earn an independent wage and be able to support herself, and this was finally achieved. Once each discovery was made, Caroline or her brother made it known, and a paper was read on her behalf to the Royal Society. On discovering her 8th comet, she got on her horse and rode through the night to Greenwich to ensure priority. On the 14th of August 1797 at 9:30 p.m, she had sat down to her work, as the skies in her domestic life permitted, of sweeping the skies with her telescope, a slow and meticulous task. However, on this occasion, having only performed the usual preparatory steps of looking over the heavens with the naked eye, she spotted her 8th comet. Given its prominence, it was not surprising to learn that others were also observing it that night, and she wanted to stake her claim first. Her impatience to deliver her news, despite having already established her name as a discoverer, led her to a rather extraordinary measures for an 18th century woman, especially one who always presented herself as particularly shy and retiring. With only the preparation of 1 hour's sleep after her night of observing, she'd ridden nearly 30 miles, despite never having, in the course of years, never rode above 2 miles at a time, to reach the Royal Observatory in Greenwich and the Astronomer Royal. Caroline's work elicited none of the condescension experienced by women in the previous century, partly to do with timing and definitely to do with Caroline's carefully crafted public image. It was during this period that Caroline was able to put all her training from working in the music industry into practice, and she was able to use her practical and theoretical knowledge to aid her brother in his astronomical work, both directly and by devising projects to work on independently. William's observations had shown that there were a great many discrepancies in the star catalogues published by John Flamsteed, which was difficult to use because it had been published as 2 volumes, the catalogue proper and a volume for original observations, and it contained many errors. William realised that he needed a proper cross-index to explore these differences, but didn't want to devote time to it at the expense of his more interesting astronomical activities. He therefore recommended to Caroline that she undertake the task, which ultimately took 20 months. The resulting catalogue of stars, taken from Mr. Flamsteed's observations contained in the 2nd volume of the Historia Coelestis and not inserted in the British Catalogue, was published by the Royal Society in 1798 and contained an index of every observation of every star made by Flamsteed, a list of errata, and a list of more than 560 stars that had not been previously included. So when William married a rich widow and their neighbour, Mary Pitt, in 1788, the union caused tension in the brother-sister relationship. Caroline had been referred to as a bitter, jealous woman who worshipped her brother and resented those who invaded their domestic lives. But I think it was more complex than that, and the change in situation affected Caroline for various reasons. Mary Herschel took Caroline's place in William's household, and Caroline was banished to the cottage next door. Such was the anger she expressed in her records of these days that she later destroyed her journals. With the arrival of William's wife, Caroline lost her managerial and social responsibilities in the household and accompanying status. She no longer held keys to the observatory and workroom, where she had done much of her own work. But because she destroyed her journals, her feelings about the period are not entirely known. When her brother and his family were away from home, she often returned there to take care of it for them. In later life, she and Lady Herschel exchanged affectionate letters, and she became deeply attached to her nephew, astronomer John Herschel. William's marriage likely led to Caroline's becoming more independent of her brother and more a figure in her own right. Caroline made many discoveries independently of William and continued to work solo on many of the astronomical projects which contributed to her rise in fame. She carried out her independent research from the flat roof of her new cottage home. Some significant discoveries include 2 of her 8 comets and NGC 253, the Sculptor Galaxy, an almost edge-on spiral galaxy. Over 20 years of ceaseless exertion, William and Caroline increased the number of known nebula and clusters from about 100 to 2,500, and this catalogue, the Great Catalogue of Nebula and Clusters of Stars, was published by the Royal Society. At age 75 and in retirement, Caroline found out that William's son John wanted to re-examine these objects systematically. Her devotion to her nephew pushed her into a frenzy of work to produce a reformulated catalogue of nebulae, and she arranged the 2,500 nebula and star clusters into zones of similar polar distances. This list was enlarged by John Louis Emile Dreyer and renamed the new General Catalogue, and now contains almost 8,000 objects. Many non-stellar objects are still identified by their NGC number. Caroline, with the support of her brother, was glad to receive recognition for the discoveries she made and for her cataloguing, both of which came about through her work within the scientific family. Unlike other celebrated male and female partnerships in science, the Herschels made little attempt to share credit for their work. Instead, in this family, Caroline's contribution was clearly acknowledged. That they were brother and sister rather than husband and wife perhaps goes some way to explaining this difference. Another plausible factor was their musical background, in which public recognition for each individual contribution was the norm. Her motivation, as far as can be inferred from evidence, was to play an integral role within William's astronomical project, to make herself indispensable to him and give herself something interesting to do. Within that framework, when she produced something that could reasonably be described as her own work, she was keen for that to be acknowledged and aware enough of her position to know how that might be achieved. She was ambitious for recognition and credit, but not ambitious for independence. And she was part of the Herschel family, but within that she saw no reason not to quietly celebrate her specific role and achievements. William died in 1822 and Caroline was grief-stricken. He left Caroline an annual income in his will, enough for her to live very comfortably. Believing she would soon die herself, she sought the familiarity of her childhood surroundings in Hanover and returned there to live with her brother Dietrich and his family. In fact, she lived for many, many more years, and unfortunately, her life in Hanover was boring and she became bitter and restless. The only thing that gave her happiness was helping her nephew with his astronomy, and she wished she had remained in England to help him more prolifically. On a visit to her when she was 82 years old, John noted, "She runs about the town with me and skips up her 2 flights of stairs as wonderfully fresh, at least as some folks I could name who are not a fourth of her age. In the morning till 11 or 12 she is dull and weary, but as the day advances she gains life and is quite fresh and funny at 10 or 11 p.m. and sings old rhymes, nay, even dances, to the great delight of all who see her." In 1828, the Royal Astronomical Society presented her with their gold medal for her work on the star catalogue. No woman had ever had it before, and no woman would be awarded it again until Vera Rubin in 1996. In February 1828, James South addressed the RAS meeting as follows: "Who participated in his toils? Who braved with him the inclemency of the weather? Who shared his privations? A female. Who was she? His sister. We stand indebted for the discovery of the comets of 1786, 88, 91, 93, 95, and many of the nebulae contained in Sir William Herschel's catalogues were detected by her." In the year 1797, she presented to the Royal Society a catalogue of 555 stars. Shortly after the death of her brother, Miss Herschel completed the laborious reduction of places of 2,500 nebulae, bringing to a close half a century spent in astronomical labour. It was resolved unanimously that a gold medal of this society be given to Miss Caroline Herschel, a vote which I am sure everyone whom I have the honour to address will most heartily confirm. Since the foundation of this society, no one has been adjudged which has been earned by services such as hers. The Royal Astronomical Society elected her an honorary member in 1835, along with Mary Somerville, although women weren't officially allowed to be fellows until 1916. In 1838, she was notified by Sir William Hamilton, Astronomer Royal of Dublin, that she had also been elected as an honorary member of the Royal Irish Academy in Dublin. And in 1846, at the age of 96, she was awarded a gold medal for science by the King of Prussia. Caroline Herschel died peacefully, almost aged 98, on January 9, 1848, at her home in Hanover. She was buried with the lock of her brother's hair beside her parents' graves in a church in Hanover. Her tombstone reads, "The eyes of her who is glorified here below turned to the starry heavens," a sentence she chose before she died. And when her restless heart finally found rest, the honorary membership of the RAS accolade was proudly recorded on her tombstone. With her brother, she discovered over 2,400 astronomical objects in 20 years. The asteroid 281 Lucretia, discovered in 1888, was named after Caroline's second name, and the crater C. Herschel on the Moon is named after her. Adrian Rich's 1968 poem Planetarium celebrated Caroline Herschel's life and scientific achievements, and Google honoured her with a Google Doodle on her 266th birthday on the 6th of March 2016. 2020 marked the 200th anniversary of the RAS, of which William and Caroline Herschel were inextricably linked. In my work as Education Outreach and Diversity Officer at the RAS, alongside the librarian and archivist Dr Sean Prosser, we celebrate Caroline Herschel with a programme of school events. We bring primary age students into the building to learn about comets, watch a comet making demonstration, and interact and allow the students to interact with Caroline's lab books and comet notes that live in the library archives. We read her journals and enjoy her beautiful handwriting, and best of all, meet Lena herself in a wonderful interactive session that can inspire all ages and people from all backgrounds, just like Caroline did when she was alive. Caroline, with the help of her brother and his friends, was able to build on the basic structure of her typically female childhood education and turn it into something scientific. Few women manage to gain this type of public reputation in science, although work on scientific couples and on invisible assistants has shown that large numbers participated. Caroline's example shows one way in which such things might be learned. To make her education and participation meaningful, she carved out a niche for herself, pursuing certain lessons and identifying tasks that needed doing. Out of this came her catalogue and her comet discoveries. Her legacy is undoubtedly lasting. There are not only the discoveries in themselves, but she was also incredibly meticulous in cataloguing and recording her discoveries and in the transcription of astronomical data. The new General Catalogue, the NGC work, is largely based on her work, and even today, many galaxies are still identified by their NGC number. I hope you've enjoyed this foray into Caroline's incredible life, the Cinderella story, where she started as a drudge for her family, moved to England, and became one of the most famous female astronomers around. She certainly inspired me into some of the activities that I do with schools and young people today at the Royal Astronomical Society. And I think that asteroids, comets, and meteors are so interesting. And it's even more interesting when we have an incredible role model to look upon and to celebrate. So thank you for being with me today, and I welcome any questions. And please do go on to learn more about Caroline and celebrate her work alongside me. Thank you very much.